Hello everyone, this is Ibrahim from Pioneer Tutoring. Today we will be going over an example from Physics 20. Before we begin this example, I'll just go over some of the key concepts. Whenever you see the term constant velocity in any given question or scenario, this indicates that your acceleration is going to be equal to zero. Whenever you see the term static motion, that means your velocity is zero. In other words, your object is not moving. Whenever you see the term dynamic motion, that is when you have things or objects moving or accelerating. In terms of friction, that is the force that opposes motion. So let's just say that I have an object, it's moving in this direction, my force of friction is going to oppose that, so it's going to be moving in the other direction. In regards to the formula for force of friction is mu multiplied by the normal force. Mu is the coefficient of friction and it's always less than 1. So mu is always less than 1. Okay. In terms of the normal force, that is the force acting perpendicular to the given surface. So let's just assume if this is my inclined plane, my normal force is going to be acting in this direction. So now let's begin with the question. So the question says, an object is moving down a frictionless surface at an angle of 50 degrees. The mass of the object is 15 kilograms. What is the normal force? So in order to do these questions, it's very useful if you start off with a diagram. So this is what my inclined plane is going to look like. I'm going to have the object somewhere along this line. In terms of the angle or the slope, it's at 50 degrees. Now we're going to be drawing in the forces. So it's very critical that you get this part right. If you don't, then the rest of it is going to be incorrect. So again, we're going to be assuming that this scenario is taking place on Earth, and anything on Earth is going to have a force of gravity acting on it. So on this object, the first force we're going to put down is going to be straight down, and it's going to be the force of gravity. Then, as I mentioned earlier, we also have a normal force which acts perpendicular to the surface. So if this is my surface, the normal force is going to be acting somewhere in this direction. And again, in the question, they assumed that it's a frictionless surface, therefore we're not going to have the friction force. Now we will start breaking this into components. But before we do that, we have to state our reference. So for this given question, we're going to say that this is my positive direction in y, and this is my positive direction in x. Okay? Any forces which are not in these directions are going to be negative. So now what we're going to have to do is we're going to break the f of g, right, this force, into its two given components. So again, the y component is going to look something like this, and the x component is going to look something like this. And this is where we have the angle. And again, I'll explain that once more. The reason why we have to break it into components is because this is what we have identified our plane to be, right? So that's why we're going to have an x component and a y component. Now when we are solving this, again, we're going to solve it we're going to solve it first in the x direction and then secondly in the y direction. So in this case, again, this is a dynamic motion because you have object moving downwards. Therefore, my sum of fx is equal to mass times acceleration. Okay. Now here, I'm going to put down all of the forces that I see in the x direction on the diagram. So the only one I have is in terms of Fg, right? Because this is Fg in the x direction and this one is Fg in the y direction. So again, now the question is it going to be Fg cosine of 50 or sine of 50? So the way to remember this is when you do cosine, it actually brings you closer to the degree sign or to the degrees that is given in the question. So when I do Fg cosine of 50, that's actually going to take me in this direction. When I do Fg of sine 50, it's actually going to take me in that direction. Okay. So again, in this scenario, we are doing sum of fx first. So it's going to be Fg sine of 50, right? Because we want to go in this direction. So it's going to be FG sine of 50. Now the second question is it going to be positive or negative? So when you take this and you do FG of sine 50, obviously your arrow is going to be in this direction, which is the positive reference point. So that's why it's going to be positive. Now we're going to do the exact same thing, but now we're going to do that in the y direction. Okay, so in the y direction we actually have two forces. So here's the first one, the normal force, and then we have the y component for f of g, which is going to be fg cosine of 50 in this case, right? So but in terms of the sign, it's going to be negative because it's opposite to what we have indicated as positive for our reference. So minus fg cosine of 50. Okay, now from unit number 1 in physics 20, you must have seen this equation. Fg is equal to mg. Now what we're going to do is we're going to label this as equation number 1 and this one as equation number 2. And we're going to solve these two equations in order to find our answer. So from the first one, we are going to have, so I'll just put this down, from equation number 1, we're going to have mass times acceleration is equal to mass times gravity, sine 50. Again, masses would cancel out because they're present on both sides. So from here, we are actually able to solve for acceleration, which is g, again, which is a constant, multiplied by sine of 50. Okay. Now from equation number 2, we are going to get, again, mass times acceleration is equal to Fn minus mg cosine of 50, right? So now again in the question we were solving for Fn, therefore we're going to isolate that variable. So in order to do that, I'm going to have to move all of this to the left hand side. So my equation becomes Fn is equal to mass times acceleration plus mg cosine of 50, right? Now what we're going to do is we were able to find acceleration from here. Mass is given in the question, gravity is known, and again cosine of 50 you can plug into your calculator. When you plug all of this in, you will get a value for f of n, which is going to be your answer in terms of newtons. So if I quickly calculate this for you guys, so I'm just gonna plug the numbers into the calculator. So in terms of the in terms of the acceleration, it's going to be 50. So acceleration is approximately 7.515 meters per second squared. Now when I plug this into this equation here, which I can actually label equation number 3, I'll solve for my normal force. So again, I'm just going to plug in the numbers. So mass was 15 multiplied by acceleration. Then I'm going to add that to mass times gravity, 15 times 9.81 multiplied by cosine of 50. And the answer that I get is approximately 207 newtons. Again, force is a vector quantity, so we have to say what is the direction. So the direction is positive, right? So therefore it's going to be in that direction. And that is my final answer. Thank you very much for listening. Make sure you like the video and subscribe to our page on YouTube. Thank you very much.